All right, mathletes, here we are finding the side lengths of right triangles using our SOHCAHTOA. Okay, so three kind of steps that you want to remember. First is redraw the figure and mark on it a hypotenuse, the opposite and adjacent side relative to the angle you're given. Two, choose an appropriate trigonometric ratio and construct an equation. Remember when doing that, our acronym SOHCAHTOA is valuable, knowing that sine is the ratio of opposite and hypotenuse, cosine is the ratio of adjacent and hypotenuse, and tangent is the ratio of opposite and adjacent. Okay, so part 3 is solve the equation to find the unknown side length. Okay, so let's look at this first example. So first what I'm going to do is I'm going to mark my hypotenuse, opposite, and adjacent. I just use H, O, and A. So looking at my angle first, okay, I see opposite my right angle. This is my hypotenuse. Okay, so opposite my angle here is my opposite side, and then my adjacent side's over here. I don't know that information. So what side do I know and what side am I trying to find? Well, that's dealing with O and H. So O and H is my sine. So I set up sine of an angle is equal to the ratio of sides. So I have opposite over my hypotenuse. And my hypotenuse, I fill in my unknown. So to solve these, I think it's easiest to set up as a proportion. So I put the sine, or whatever trig function you have, over 1, and I'm going to cross multiply. So in order to get x by itself, I'm going to multiply both sides by 10, or I can think of it like this, that 1 times x is x, and this is equal to 10 times 50, the sine of 58. 10 times the sine of 58 degrees. Okay, using my calculator, so I already have x by itself. So using my calculator, I can do 10 times the sine of 58, and that's equal to 8.48. Since I'm dealing with geometry, I'm thinking about units, and this is centimeters. This answer should make sense because it's shorter than my hypotenuse, and proportionally it seems to be about right. Okay, so let's look at example 2. So in example 2, okay, I'm going to follow my first steps. On all these, I always like to make sure I have my SOHCAHTOA written on the top of my paper so it's easy to identify which one I'm going to use. Okay, so I have my angle here. My right angle's here, so opposite of that is my hypotenuse. Opposite of my angle that I know, so this is opposite, and this is adjacent. Okay, well, I know my opposite side, and I'm trying to find my adjacent side. I'm not using my hypotenuse. So opposite and adjacent is going to lead me to tangent. So setting up my trig ratio, I have the tangent of some angle, which is 39 degrees, is equal to the opposite side, so that's 8, over my adjacent side, which is x. Okay, so remember, to solve this, I'm going to put this over 1, and I'm going to cross multiply. So here I do 1 times 8, and I get 8. This is equal to the cross multiplication here of x. Well, I have x times the tangent of 39. So I'm not done. In the previous problem, we were done after just doing cross multiplication. I know I'm not done because my x is not quite by itself yet. Well, it's being multiplied by tangent of 39, so to get x by itself, I just undo that multiplication. So I divide by tangent of 39, divide by tangent of 39. So then as I get x by itself, I got x is equal to this side. 8 divided by tangent of 39. So putting that in my calculator, I do 8 divided by tangent of 39. And I see that that's equal to 9.88 to 3 significant figures, and I'm dealing with meters. Okay, as I put it over here, it's 9.88, and I should think, all right, if this angle is 39 degrees, these angles are complementary, so they have to add up to 90 degrees. So this is going to be 51 degrees. So since this angle is larger, its opposite side should be larger than this 39 degrees. Well, 9.88 is larger than 8, so that makes sense in the context of this problem. So it's always important to kind of bring it back together and make sure your numbers make sense. That concludes our notes tonight on finding side lengths of a right triangle using trigonometry. Highlight any questions you might have and bring them to